Hey everybody, how you doing? I hope you're doing well. In this video, I want to talk about the IBM check digit scheme. The IBM check digit scheme, well, the most common use that I know of is validating credit cards. Credit cards follow a multi-step validation process. There is a client side or a first stage validation, and the IBM check digit scheme is used for that. So let me jump into what the IBM check digit scheme is. So the IBM check digit scheme is a mod 10 system, and it's an sigma alternating sum. And sigma is a function, and it's represented usually in a permutation notation. Specifically, 0 is going to go to 0, 1 is going to go to 2. We're always going to read these left to right unless we hit a parentheses and then we cycle back. Permutation notation is also known as cycle notation. So let me continue with this. 1 goes to 2, 2 goes to 4, 4 is going to go to 8. In fact, it's basically doubling unless I get to a 2-digit number. Once I get to a 2-digit number, I add digits together. Well, what does that mean? 4 plus 4 is 8, 8 plus 8 is 16, but 16 is a 2-digit number. If I have a 2-digit number, I'm going to add those 2 digits together. 1 plus 6 is 7. Now 7 plus 7 is 14. Again, that's a 2-digit number. 1 plus 4 is 5. Now 5 plus 5 is 10. That's a 2-digit number. 1 plus 0 is 1. But 1 was already on my list in this particular cycle. I need to make sure that I have a function for every digit. 0, 1, 2, I'm missing 3. I'm going to start a new cycle. Write down the number 3. Now I'm going to start this doubling process. 3 plus 3 is 6. 6 plus 6 is 12. But 1 plus 2 is 3. That's on my list already. Close it up. What number haven't I seen here? The number 9. 9 plus 9 is 18. That's 2 digits. 1 plus 8 is 9. And that's just all by itself. That's why 0 is by itself. What's 0 plus 0? Well, it's still 0. So this is called the sigma function. So let me get to the scheme. If I have an n-digit number, a valid number satisfies the sigma sum such that the sum is congruent to 0 mod 10. I already said this was a mod 10 system. Now this last piece here may be just A1, or it may be sigma of A1. It depends on if n is even or odd. Now, the way I wrote this, the last digit, the check digit, AN, never ever has a sigma attached to it. But depending if n is even or odd, it's going to affect what's happening to the first digit. So let me talk about a number here, 38754319. Now this isn't a credit card number. Credit card numbers have 16 digits. Well, most of them do have 16 digits. I'm going to pick a small example so we don't have lots of computations to do. What I like to do, this little road that I put down here, I actually did this from right to left. I always start with the last digit as a 1. That's the coefficient right here. The second to last digit has a sigma attached to it. So I just alternate. That's the whole idea of sigma alternating. 1 sigma, 1 sigma, 1 sigma, and so on. This could have 16 digits in it. 3 sigma means find the 3, move 1 to the right. Unless you were on the right, you would cycle back to the beginning in that specific cycle. So 3 becomes 6, 8 times 1 is 8, 7 sigma is 5. Oh, 7 sigma is 5. 5, 1 is 5. 4 sigma. I'm saying 4 sigma. I really should say sigma of 4. But the way I'm pointing to this, I'm just reading the way I'm pointing to it. Double 4, I get 8. 3 stays alone. Double 1, I get 2. 9 stays alone. If I add these up, I get 46. But 46 is 6 mod 10. It's not 0. So this is not a valid number. 3, 8, 7, 5, 4, 3, 1, 9 is not valid. And what I mean by not valid, it's not a valid IBM number. So here's an example of something that is valid. I'm going to take this number, and what I did is I rewrote this, and I changed the 3 to a 7. Well, changing that 3 to a 7 actually increases the sigma sum by 4. Because 3 was attached to a 1, so raising the 3 raises that part of the sum to 7, and now I'm going to get 50, which is congruent to 0 mod 10. So the number 38754,719 is a valid IBM number. Is the scheme any good? Well, one of the first checks I want to do is, does it even check or detect transpositions? So here's a quick example. Does it check transpositions? Here's the number that we just determined there was a valid IBM number. I'm going to switch the 7 and the 5. So if I do the sum, the sigma sum, on my new number, I wind up getting 46, which again is not 0 mod 10. So I want to do a small little calculation here and try to convince you that if this is a valid number, this one cannot be. So what is my sigma structure on here? There's always a 1, and these alternate. Sigma, 1, sigma, 1, sigma, 1, sigma. And there's a 1 up there. So in this particular sum, in the sum, I have a sigma of 7 plus a 5. But in this particular sum, the B sum, I would have a sigma of 5 plus a 7. Now, all the rest are the same. So when I subtract these two, when I do the sigma sum for A minus the sigma sum for B, and I'm calling this top number A here, what's my result here? Well, my result here is going to be sigma 7 minus 5 minus sigma 5 minus 7. Oh, sorry, plus 7. And this should be congruent to 0 mod 10 if A and B were both valid. But this little equation comes out, it's very nice actually. I can manipulate this equation to wind up getting something fairly nice. I get sigma 7 minus 7 is congruent to sigma of 5 minus 5. And this is all in the mod 10 system. And the thing is, that's not true. Sigma 7 is 5, minus 7 is negative 2. Sigma 5 is 1, minus 5 is negative 4. Negative 2 is not the same as negative 4, so this isn't going to work. Now, why did I show you this little calculation here? Well, that comes down to this little question I have for you. Can you show if I have two digits, I'm going to take out 0 and 9 because, well, 0 and 9 are not changed by the sigma. And we switch them. Can they both be valid numbers? Well, what you eventually have to show is that if you have the following idea that these are only congruent to each other mod 10 when AK and AK plus 1 are the same. So in other words, that they're both valid numbers if these digits were exactly the same to begin with. So I want you to think about that. And that's all I have for right now. If you have any questions, let me know.